Ellipses. So similar to locus and loci, the plural of focus is foci, not foci. Okay, so the locus definition of an ellipse is the point that moves so the sum of its distances from two fixed points remains constant. So here are our foci, F1 and F2, and this distance here plus this distance here remains the same. D1 chain could get shorter or longer, D2 could get shorter or longer, but D1 plus D2 remains constant. The standard form of the Cartesian equation of an ellipse that's centered at the origin is like this, where A is the radius in the horizontal direction and B in the vertical direction. And obviously, unlike the radius of a circle, this does not remain constant. If A were to rotate, this length would change. And we always have them equal to 1. This ellipse here has x-axis intercepts at positive A and negative A, and y-axis intercepts at positive B and negative B. Now I can apply the translation, h units in the negative x direction and k units in the positive y direction, and we can get this. I said positive, I don't mean that. So we can add h to x and we can add k to x, and that gives us this Cartesian equation of an ellipse, which is centered at the point hk. And so it would look like this. So let's have a look at a few equations of ellipses and what their graphs look like. Our first one, we can rewrite the denominators as squares because that will help us with where our axis intercepts are. My centre, because nothing is being added or subtracted from x and y, my centre is at 0, 0. My intercepts are at positive and negative 3 on the x-axis and positive and negative 2 on the y-axis. So it's going to look like this. If you're sketching an ellipse, it's a good idea to mark the points on your axes. This 2 needs to be the same distance from the 0 as this negative 2. And similarly with the 3, make sure they're symmetric, and then try to join them up without making it look like a parallelogram. Here, I need to rewrite this to get where my x and y intercepts are. If I've got 4 multiplying the x, then that's the same as dividing by a quarter, which is a half squared. So this has a centre at 0, 0. X-intercepts at positive and negative half, and y-intercepts at positive and negative 1/3. Because these are on different diagrams, it doesn't matter that they look pretty similar. If they were on the same diagram though, obviously I would have to show that this one is much smaller. Make sure my scale is accurate. Okay, for C, we've got some translation of the origin, some translation of the centre happening. My centre is at 1, negative 2. My x-intercepts are when y equals 0. So I substitute y equals 0 into my equation and then solve for x. You might, for now, you can do that on your CAS. You might need to do that without your CAS though. And then similarly, the y-intercepts are when x equals 0. So I substitute x equals 0 into my equation and solve for y. And so this is what it looks like. Now to sketch these, we know that our width is 2 in either direction. We know that our height is 3 in either direction. And because I know where my centre is, I can work out how much it crosses the x and y axes by. And then I can calculate these just to fill in the proper coordinates. Pause the video now while you have a go at questions 1 and 2. Note that my book was missing a 6 from here. And these are your answers. So, the German mathematician and astronomer Johann Kepler in 1609 discovered that the planets' orbits of the Sun follow elliptical paths and not circular ones, as was originally thought. There is a video under this one which shows how you can draw an ellipse using this particular method. Okay, so let's have a look at finding equations of ellipses given information. Here I've got AP plus BP equals 8. These are my points A and B. So if x and y are my coordinates of P, and I have this sum, then using the distance formula, I can say this. So that comes from x subtract negative 2 all squared, y subtract 0 all squared, and so on. Now, previously we squared both sides, but that's not going to make things any easier for us here. So I'm going to add another step in. I'm going to subtract one of them. It doesn't actually matter which one. So I have this. Now I'm going to square both sides. Then I'm going to expand these brackets. And then I can simplify. I can subtract 4 from both sides. I can subtract y squared from both sides. I can subtract x squared from both sides. I can add this 4x to both sides. And so I get this. Now, it's a really good trick to stop at this point and have a look if there is a common factor that you can divide by, which will make your calculations much easier. Here I have a common factor of 8. So I can divide everything by 8, then I can subtract this, which is now an 8, from both sides. Now I have a much simpler equation, still not the simplest, it still has a square root, which I don't really like there. So I'm going to square again. Now I can be careful here. The negative obviously disappears when you square it, but you've got this 2 that needs to be multiplying everything that was under the square root. Expand this bracket and again simplify. Remember that we want to have equal to 1, and so I need to divide 3 by 48 to get this. Now, if I were asked to sketch this, I would rewrite my denominators as squares. Nothing's happening to the x and the y in the numerator, so my centre is at 0, 0. My intercepts are at positive and negative 4, positive and negative 2 root 3. And it would look like this. Pause the video now while you have a go at questions 3 to 5. And these are your answers. Now, there's another way that we can describe an ellipse as a locus, and it is as follows. It's going to be easier with a diagram. So it's where the distance from the focus to a point on the ellipse is equal to some value multiplied by the distance from a directrix to the ellipse. And this value must be between 0 and 1. It's called E because it's known as the eccentricity of the ellipse. And from the symmetry of this being on this side, there is a mirror image almost on the other side here. So that's how our ellipse still has 2 foci. Okay, so let's have a look at finding the equation of an ellipse using that kind of definition. My distance from F to P is x minus 1 all squared plus y squared square rooted. And then be really careful, it's a half times MP. So a half times the square root of x plus 2 all squared. And remember, this is useful to write it like this because I'm going to square both sides. So don't just write x plus 2. So I square both sides. Then I'm going to expand the brackets. And I've multiplied by 4 to get rid of the fraction. Now I can expand these brackets here and collect up like terms. I need to complete the square for x here. And then I'm going to divide everything by 12, so I've got an equation that's equal to 1. So I can see that this ellipse has a centre at 2, 0. And we can see that these won't be its intercepts, but its width is going to be 2, and its height is going to be root 3. Okay, so now you can have a go at questions 6 and 7. And these are the answers.